Question 17, we have 7 counters with numbers on them like shown. Ali puts the 7 counters in the bag. He takes at random a counter from the bag and does not replace it. So once he's removed the first counter, there will be one less remaining in the bag afterwards. He then takes at random a second counter from the bag. So calculate the probability that the number on the second counter is 2 more than the number on the first counter. So imagining one at a time, taking these. If we took a 1, a 2, a 4, a 1, a 2, a 4, or a 5, is there a number that is 2 bigger than it that we could take next? Well, if I take a 1 first, then that would mean that we need a 3, doesn't exist. If I take a 2 first, that means we would need a 4, so that works. If I take a 4 first, we would need a 6, doesn't exist. And if I take a 5, we need a 7, also doesn't exist. So basically what this question is asking is that we take a 2 first, then a 4. So, probability of taking a 2 to begin with, there is 1 out of 7. Probability of getting a 4 afterwards, this 2 no longer exists. We will have 2 4s out of a possible 6. And the fact that we have this then, also known as AND, means that we're going to be multiplying these probabilities together, because both of these things have to happen together, which gives us 2 over 42, which simplifies, although you don't need to simplify. Your calculator will do it for you. 1 over 21 is the probability for that. Part 2, the number on the second counter is 1 more than the number on the first. So go through the motions again. If I pick a 1 first, a 2 next, that will work. If I pick a 2 next, there is no 3, so that doesn't work. A 4 next, there will be a 5. So we've got 2 different options here. We've got the probability of a 1 first, then a 2. And we've also got the possibility of a 4 first, then a 5. The fact that we've got either of these means that we have an OR. And an OR basically is when you've got more than one option of doing something, probability-wise. You add these together, because the more options you have, the greater chances of something happening. Not to be mistaken, though, for the fact that contained within each of these is a then or an and. So you've still got your multiplying. The 1 and the 2 have to happen, and the 4 and the 5 have to happen. We don't need these in brackets, but just to kind of show that they're separate calculations to begin with, you're going to calculate this 1 and 2 and 4 and 5 first, then add the answers together. There was one number 1, and there is one number 2. Of course, it's out of 6 second time because we've lost one. So that gives us 1 over 42 for the first fraction. And for the second fraction, we have 2 4s out of 7, followed by 3 5s out of 6, because we would have lost one of these 4s. It doesn't matter which one I cancel out. There will be 3 5s out of 6 remaining counters. So we have 2 out of 7 times 3 out of 6, which gives us 6 out of 42. That's kind of nice that they both have the same denominators. It might not always happen that way, but in this instance it does. We end up with 7 over 42, which you don't need to simplify it, but if you did, 1 over 6 is your final answer. Done.